Okay, 4.4, the fundamental theorem of calculus. Woo! Exciting.
I just want to get the short way done now.
Okay, so we gotta get there. Are you guys headed?
Yeah.
Okay. Okay. So the fundamental theorem of calculus states that the integral from a to b of f of x dx is f. Now, when we go backwards, that means the answer, right? Like that was the original function?
FB is?
Yeah, f. F.
Just F, yeah.
Okay. So I find the integral. We know how to do that. And then I plug in the upper limit and subtract it from when I plug in the lower limit.
Okay.
That's what it is.
That's the shorter one?
Yep. No limits. No summations. How's that sound? No limits and no summations? Amazing, right?
That just is math terms in my head.
Ready?
Mm-hmm. Yep.
Okay, so you don't have to write all this. Just look. See, this is just what we just... I touched it. This is what we just wrote down, isn't it?
Yep.
Okay, so just follow me. Okay, here are the guidelines. If you want to write them out and really detailed, they are in your book. Or you could go back and watch this. Okay, number 1, provided you can find the antiderivative or the integral of f, you have a way to evaluate the definite integral without having to use the limit or the sum. That's what we were using in 4.3. We don't want to do that again. We'll have to do it for the test, but we don't want to keep doing it, do we? So, this is the method. We find the integral, and then we go from a to b. We write it like this, and then we plug it in. This is just an example. So I have the integral from 1 to 3 of x cubed dx. So the integral of x cubed would be x to the 4th over 4, correct? Correct?
Why?
Because 3 plus 1 is what?
4.
4. And then you divide by 4?
Why do you divide by 4?
Because that's how you find the integral.
Oh, are we doing like the...
We're finding the
x and minus 1?
yes,
Okay.
plus, but plus.
Why is it plus?
Because it's the integral.
I
It's
thought it was
minus.
minus.
It's minus when it's derivative. It's plus when it's integral. You're undoing. So from 1 to 3, and then it's just, I plug in 3, I plug in 1, so I have 81 over 4 minus 1 over 4 is 20. Okay, much quicker than what we were doing, correct? Okay. If we have something like this, it is not necessary, well, this is saying it is not necessary to include the c. Remember when we found integrals, we were always including the c? Plus c, plus c, plus c, plus c. Okay, this is going to show you why you don't have to do the c. So when I do it out, I have f of x plus c from b to a. So I plug in b, I plug in a. Well, I distribute this negative, correct? Right there? Mm-hmm. So that would be positive c minus c, which would be what? Plus c minus c would be what?
0.
0. So does it even matter to be there?
No.
Nope. So when we do these, we aren't putting the c. The whole thing was just, we're using this now. Okay, so examples. So I need the integral from 1 to 2 of 2x minus 3 dx. Mm-hmm. Now we know that we take the integral of 2x squared minus the integral of 3, correct?
Yeah, so we can...
Okay, so we add 1 to 2 is what?
3.
3, so x cubed over 3, correct?
Yep.
And minus, and the integral of any constant is just x, correct? Do I need to go over y again?
Nope.
Okay. From 1 to what?
2.
2. So now we're plugging in 2. We plug in the upper limit minus when we plug in the lower limit. So I have 2 cubed over 3 minus 2 minus 3 times 2. Yes.
Mhm.
Minus 1 cubed over 3 minus 3 times 1. I plugged in B and then I plugged in A, correct?
Yeah.
Now think about it, guys. We want area, right? That's what we're looking for. That's what the integral does, the area under the curve, correct? So when I do that, I always subtract bigger things from smaller things when I'm finding differences, right? That's why we do B minus A. So 2 cubed is
8.
8, so we have 8/3. And this is going to be 6, but we need over 3, so it's going to be what?
No. 18/3.
Okay, so 18/3 minus 1/3
Yeah, 1/3.
plus.
Why would it be plus?
Why would it be plus?
Oh, because the minus.
You have to distribute that minus, don't you? Okay, plus 3, but we need it over 3. We need this 3 over
3.
9 over 3. We just got common denominators, right? So these two together get me negative 19, right?
Yeah.
Plus 9 would be negative 10.
Yep.
So 8/3 minus 10/3 is
Negative 2/3. And that's it?
mhm. So my answer is okay. So the next one we need to rewrite before we do anything with, don't we? 1 to 4. 3 in the front, right? 3 in the front. X to the what?
Half.
Half. Dx. I can't keep writing it over there. I don't have enough room. So I'm going to have 3. And now I need the integral of x to the 1/2. So 1/2 plus 1 is
1. No.
1/2 plus 1.
Half.
1/2
2 over 2.
plus 2 over 2.
3.5.
So 3/2 divided by 3/2, right? From 1 to 4. Well, when we divide by a fraction, we multiply by the
Reciprocal.
reciprocal. So that's going to be 2/3 x to the 3/2.
Yeah.
1 to 4. Okay. Well, this 2/3 we can also deal with right here, right? So what's 2/3 times 3?
2.
2. So I'm just going to leave it out in front. I could put it in, but I could just leave it out in front, can't I? Okay. So I need to plug in 4. So I have 4 to the 2/3. How about 3/2, not 2/3? Sorry. Minus 1 to the 3/2, correct?
Why would it be minus?
Because that's the formula.
Oh.
Okay. Well, in the 3/2, the 2 tells me square root, correct? So what's the square root of 4?
2.
2. So I'm really doing 2 cubed, aren't I?
And then you would be doing 1 cubed.
Well, 1, yeah, just 1, right? So what's 2 cubed?
8.
8. So we have 2 times 8 minus 1. So we have 2 times 7. So we have
14.
14. Much easier than we've been doing?
Yeah.
Okay.
Oh.
Okay. So we have the integral of the secant squared x dx from 0 to pi over 4, correct?
Uh-huh.
So what is the integral of secant squared?
I don't think it's in my notes.
Or it should be on your derivative integral sheet that you should have. Correct?
I don't even have that.
Why don't you have those? I've told you guys.
Yeah, and I didn't do it.
Is there a reason why I've told you guys?
What derivative English? She wanted us to write.
I wanted you to write this. Remember the derivative sheet?
I didn't.
And if I have a derivative sheet, can't I just go backwards to do the integral? Yes?
I thought we did that.
Well, you should have the sheet somewhere. Okay, so I see that the derivative of tangent is secant squared, so the integral of secant squared is what? Tangent. So the integral of secant squared is, just told you, tangent, right? So I have the tangent of x from 0 to pi over 4. So we're going to have tangent of pi over 4 minus the tangent at 0. Well, what's the tangent of pi over 4?
Tangent's y over x, right?
Mm-hmm. And pi over 4 is 45, so y and x are the same.
Would be 1.
So it's 1. What's the tangent at 0?
Um, 0.
Mm-hmm. So the answer is
1.
1. Guys really need to get the sheets.
I'm trying. Okay. Was it in one of our videos?
No, I did.
It's in
You
the
were just
book.
supposed to combine them, like product, quotient, chain, and then all the tangent, because they were from different units. I think in 4.2 was a whole sheet of them in there, I think, in your book.
Because I remember seeing it up there on the board, but
And I think I made a boo-boo by putting this all on one. I think I made a boo-boo.
okay.
But you need this today, because I don't have enough of them on here. But I was just seeing if you need it today. What are you doing? What numbers today?
6 through 22 even. Oh, no. 5 through 21 odd and 27 through 31 odd.
Okay, so you don't need this example today because we need more work. And, okay, your calculators. Take your calculator out. Okay, hopefully this works because this is a new calculator. When I made this PowerPoint, everyone in my room had new calculators, not those. Okay, so you should go to where first? Where does it show first? Math. And when you hit math, do you see something about an integral maybe? Scroll down.
Yeah.
Yes, number 9, right?
Yeah.
Okay, it is number 9 right here.
Okay.
Okay, you're going to push that Okay. Now, on the newer calculators, it legitimately puts it like this. So you know exactly what you're doing. Okay? I'm hoping that we put the lower the limit, the upper limit, the equation, and then the variable. I'm hoping that's how that works. Okay, so our first example, not our first example. Let's get us an example so we already know the answer. That'd be good, huh? So, how about we do 3x to the 1/2? Okay, so our second example was from 1, comma, 4, comma, 1 to 4, right? That was our second example. You're looking at it on your piece of paper, 1 to 4, A, B. Now the equation was 3x.
Do we put that all together?
You're putting 1 in the parenthesis. In the parenthesis, you have this on your screen right now, correct?
Yeah.
Okay, and then put a parenthesis. So 1, comma, 4, comma, 3x to the 1/2, comma, x, parenthesis. And I think the 1/2 you have to put in parentheses,
Yeah.
comma, x. Go to syntax. Didn't work. It said syntax, didn't it? See, this is what you do when you don't know how. Because on this, it honestly comes up with that, and you just fill it in. Oh, shoot. That's not I. Nope. FN I N D. Oh, well.
How'd you put FN?
Might as well plus right, too. Okay. Okay, so when you guys ever look these up, you need to make sure you're in an 83 plus, because that's what you have. Okay, because if you go to the other ones, they're going to show you the ones that have it.
If you want to achieve better results, make a great impression, and save time at work, you should get great.
Hi everybody, today I'm going to show you how to integrate on the TI-83 Plus. So,
We know where to find it.
and the last two arguments with respect to that. And I'm just going to start with a very simple function, and the first argument is the function, and I'm going to start with x squared.
Okay, so the first argument's the function. Do you have it on there? Do you have the FN in? You got it? So our function was 3x to the 1/2, right? Comma. So the first thing's your function.
So it's okay.
Oh, dude, go back. I thought I hit pause and I
Very
hit mute.
simple
Okay.
function, and the first argument is the function.
So we put the function
And
in.
I'm gonna start with x squared, and this is with respect to x. And the last two arguments,
Okay, that's easy then. Okay, so you put your function in first, which was 3x to the 1/2, right? Okay, and then, let me go back to my PowerPoint so I can write on it. Okay, so you went to math. You went math 9. Okay, so you have the F, N, I, and T on your calculator. You put the function, which was 3x to the 1/2, right? And remember, put parentheses around that, comma, with respect to x, comma, from what was our lower limit?
1.
1, comma, what was our upper limit? 4. End your parentheses and enter, and you should get what we got.
Got 11.25.
I got 14.
What?
Did you put parentheses around this? Did you put it as an exponent?
What do you mean exponent?
Because it's to the 1/2. Because it's 3 squared of x,
No.
which is
I
3
don't know how to do that.
caret.
Oh my god. Hate calculating.
Okay, so your calculator will do it for you. You also have the integral calculator that I've shown you, the derivative calculator, and you just go to the top and hit integral, and it will undo it. Did you get 14 yet?
Alright. It takes a while, okay?
Okay,
There's so
I
much
just
going on
asking.
right now.
So I was putting the right stuff in the wrong order.
Yeah, I got 14.
Okay, so your calculators will do them for you.
But you won't let us use them on a test, I bet.
Probably not. Okay. This we do not need until Thursday. So do you want me to wait till Thursday to give it to you?
Yeah.
Okay.